This podcast is about solving problems using dimensional analysis, which means using units and making sure that our answer is in the correct form and we can be confident that we've done the right calculation. So I'm going to go over dimensional analysis, which is also called factor label method. If you hear that, we're talking about exactly the same thing. I'm going to go through this in pretty great detail, so if you're unclear, it might help to go back and watch this a couple times after you have the notes. So if we look at a question, how many eggs in a dozen? We know that 12 eggs are in a dozen, and we call this our conversion factor, which means that two things are equal to each other. Another way to think about it is we use the word per all the time, and what I'm realizing is this is causing quite a bit of confusion for students because we don't really understand what it means. And what per means is per one. And we often leave off the one, but it can be really useful to always keep that one in there. It'll help you know what to do with your numbers when you get stuck. So we can write a conversion in two ways which are absolutely equal to each other. We know that 12 eggs equals a dozen, or 1 dozen is equal to 12 eggs. So both of these are equivalent, yet we got to pick the one that's going to cancel the units the way we want to. So practice making conversion factors for the following equivalencies. And you've got more of these in your packet, but just do enough that you understand what we mean by setting up a conversion factor in a fraction form. So 1,000 milliliters is equal to 1 liter. 1 liter is equal to 1,000 milliliters. And I picked ones that were pretty common. So 3 feet is equal to a yard. 1 yard is equal to 3 feet. It is really important for all of these to absolutely write out the unit, not just the number, because the unit is what you're really going to pay attention to. So we know from math, when a top number and a bottom number are equal to each other, 3 feet and 1 yard are exactly the same thing. If we multiply by this fraction, we're just multiplying by 1. All we're doing is changing the form. We're actually not changing any values. So how to think about how to use that fraction to set up our equations using sort of algebra methods. If we have a 2 and the 2 is on the bottom, we multiply by 1 over 2, so the 2 is on the bottom. The 2's are going to cancel. If we have a 2 and the 2 is on the top, they are not going to cancel. So what we always want to do is think about putting the units that we want to cancel on the bottom. So how would you choose, if two possible conversion factors, two forms, which one to use in order to cancel a given unit? The unit that we want to cancel is going to go on the bottom, and I'll show you what I mean by this. So here, we're going to pick one of the conversion factors that are in your packet. So on the same page, I didn't rewrite them all in the podcast, but they're all there on your notes. Which one to use to get the form that will cancel the right units and get us the answer? So if we have 3 tons and we want to convert to pounds, the math here is already done. We're just going to think about the units. From tons to pounds, we know that we're going to use the conversion factor that says there are 2,000 pounds in 1 ton. Okay? And because I'm starting out with tons and I want tons to cancel, tons goes on the bottom. So therefore the 1 is going to go on the bottom, and then pounds is going to go on the top. So therefore my answer will be in pounds. Tons will cancel, pounds will be left. Again, if we are converting from calories, 4.5 calories, how many joules is that? We know that for every 1 calorie, we get 4.19 joules. But because calories needs to cancel, 1 calorie is going to go on the bottom, 4.19 joules is going to go on the top. Then because the number is on the top, we're going to multiply 4.5 times 4.19 and get our answer, which is 18.89 joules. And these are not rounded, actually. So how would you set up a dimensional analysis problem? So here's a typical problem. 1 inch is equal to 2.54 centimeters. That's our conversion factor. How many inches are equal to 4.5 centimeters? This is our given. This is the given measurement that we're going to start with. So you have to identify the given and write it down. 4.5 centimeters. We know that we're given the units of centimeters and we want our answer in inches. So figure out where you're starting, which is our given, and where we want to go, which is what we want to find out. Later when we get into chemistry, I'm going to label stuff given and want. So I want you to see it here, but it's really, really useful later on, so I wanted to introduce it at this point. So choose your conversion factor. In this case, we know that 1 inch equals 2.54 centimeters. That is our conversion factor. Decide if you want inches on the top, centimeters on the bottom, or centimeters on the top and inches on the bottom. Because we're starting out with centimeters, and centimeters has to cancel, centimeters is going to be on the bottom. So do the math. Set up your equation. 4.5 centimeters times 1 over 2.54. Because 2.54 is on the bottom, we're going to divide and then calculate the answer, 1.7717. So I forgot to mention this. So once we have our answer, we have more digits than we need, but we know that 4.5 only has 2 sig figs. So the answer is also going to have 2 sig figs, and we're going to round to 1.8. So I went ahead, but for practice, go through and show your work and cancel the units and do the 2 problems that are on this page, and then continue the video. Pause the video, do the problems, and then continue the video and check your work. This one's already shown. So for the first one, our given 72.5 yards. We know that 1 yard, it's going to be on the bottom because it has to cancel, is equal to 3 feet. Yards cancels. Because 3 is on the top, we're going to multiply. And we get 225. And then because our starting measurement has 3 sig figs, our answer should have 3 sig figs. And I rounded this to 2, and I don't know why I did that. It should just say 225. How many gallons of milk are purchased? If you need 75 quarts, 1 gallon is equal to 4 quarts. So 75 is what we're starting with, times quarts is going to be on the bottom because quarts has to cancel the unit. Gallons is on top. 1 gallon is equal to 4 quarts. 4 is on the bottom. We divide by 4, 18.75. Because we only have 2 sig figs in 75, we should have 2 sig figs in our answer, which is 19, and that's gallons. Oh, I fixed it. 218. I was looking at old notes with old keys, and I hadn't redone the math yet, so if you got 218 feet, it definitely, that is definitely the correct answer. Sorry about that. Okay, if we're converting between metrics, we're going to use this graph here in this form, and I'm going to show you how to use it. So you're probably familiar with a lot of these prefixes, kilo and giga, milli, micro. You don't have to memorize them. You're not going to use that King Henry rhyme. You're just going to learn how to use the chart, this chart. So in this chart, the way it's done, the prefix always has the 1, okay? So by prefix, we mean kilo and kilometer, nano and nanogram, femto and femtoliter. The ending piece is the base unit. That is not the prefix. The beginning piece is the prefix. So 1 kilometer is equal to how many meters? Meters is the base unit. We're always converting back and forth to base units. So what we do is we go over here and find kilo, and it's little k. It means 1,000. which is 1,000, or 10 to the minus 3. They are exactly the same thing. Here I wrote down 1,000. I could have written down 1 times 10 to the third. 1 nanogram. Go over here and find nano. N. It's a billionth. Do not write out the word billionth. It is point lots and lots of nines followed by a 1, or 1 times 10 to the minus 9. You're going to want to use scientific notation here because no one wants to count all those zeros. So it's 1 nanogram. Remember, nanogram gets the 1 because it has the prefix. Is 1 times 10 to the minus 9th grams. That's how many base units. 1 femtoliter, 10 to the minus 15 liters. And then we're going to use these conversion factors to solve conversion problems, just like we did with the eggs and feet and tons. So pause your video, go through and try to do these. If you get stuck, restart the video because I showed all the work in all of them, and you can see how they were done and check your answers. So how many centimeters in 2.784 meters? So write down our given with its unit. This is the conversion factor, just like we saw before. Meters has to go on the bottom because meters has to cancel. Centimeters goes on the top. Centimeters gets the 1 because it has the prefix. And then from the chart, we know that centi is 1 times 10 to the minus 2 meters. And then we just plug it in our calculator and calculate. Okay, check all your answers. Cubics are really tricky because we have meters cubed and we don't have that on our chart. However, we do have meters and centimeters, but then you have to cube the whole thing, which means you have to cube the 1, which does nothing, and you have to cube 1 times 10 to the minus 2 before you divide by it. Because it's on the bottom, you're going to divide. And that gives you a really big number of cubic centimeters, which does make sense. If the units are getting smaller, the number should get bigger. So do the worksheets in your packet, and the keys to the worksheets are in Schoology. Let me write that down. So the keys to worksheets are in Schoology. In Unit 1, there's a Unit 1 folder, and then there's a folder marked keys. If you can't find them, make sure to ask me. But do the work and check your answers with the keys.